The Witwatersrand is a 56-kilometer-long north-facing scarp in the Gauteng province of South Africa. It consists of a hard, erosion-resistant quartzite sedimentary rock, over which several north-flowing rivers form waterfalls, which account for the name Oe Witwatersrand meaning the edge of Whitewater in Afrikaans. This east-west running scarp can be traced with only one short gap from Bedfordview in the east, through Johannesburg and Roodepoort, to Krugersdorp in the west. The scarp forms the northern edge of a 7 to 10 kilometer wide plateau which rises about 200 m above the surrounding plains of the Highveld. The entire plateau-like structure is also often called the Oe Witwatersrand. The plateau unregistered trademark S elevation above sea level is between 1700 1800 m. The Witwatersrand Plateau forms a continental divide with a run-off to the north draining into the Indian Ocean via the Crocodile and Limpopo rivers, while the run-off to the south drains via the Vaal into the Orange River and ultimately into the Atlantic Ocean. The Witwatersrand lies within the province of Gauteng, formerly called the OEPWVA, an acronym for Pretoria, Witwatersrand, and Vereeniging. When used in this latter context, the term Witwatersrand refers to the entire Greater Johannesburg metropolitan area. This conurbation is oblong in shape and runs from Springs in the east to Randfontein and Carletonville in the west, as well as Soweto to the south. This area is also often colloquially referred to as Oethrand or Oewitsa. Because of the extraordinary quantities of gold that have been extracted from the Witwatersrand rocks, the South African currency was named the Oe-Rand in 1961. Geology of the Witwatersrand Ridge. The Witwatersrand Plateau consists of a 5,000 to 7,000 meter thick layer of mainly sedimentary rocks laid down over a period of about 260 million years, starting approximately 2970 million years ago. The entire series of rocks, known as the Oe Witwatersrand supergroup unregistered trademark consists of very hard erosion-resistant quartzites, banded ironstones and some marine lava deposits, interspersed with softer, more easily eroded tillites, mudstones and conglomerates. The oldest rocks form the northern scarp of the Witwatersrand Plateau. The youngest are those that form the southern edge of the plateau. Gold is found in the conglomerate strata of the younger members of the supergroup. The abundance of this gold is without equal anywhere else in the world. Over 50,000 tons have been mined from these rocks since this precious metal was first discovered here in 1886. This accounts for approximately 50% of all the gold ever mined on Earth. Not all the conglomerates contain gold, and of those that do, the gold is not uniformly distributed throughout the layer, but tends to occur in streaks, where the pebbles that make up the conglomerate are larger than elsewhere. Here the gold is associated with other minerals, especially iron pyrite and uraninite, as well as carbon-rich materials such as kerogen, or bitumen, which occurs in small balls less than 1 mm in size, called a oophospec carbon or as continuous layers about 10 20 mm thick. The gold-bearing conglomerates occur chiefly in the upper, younger layers of the Witwatersrand supergroup of rocks, on the southern side of the Witwatersrand Plateau. The Witwatersrand supergroup strata which reach the surface in Johannesburg dip downwards to the south at an angle of about 30 degrees. From there on they are almost everywhere, with very few exceptions, covered by younger rocks. Gold mining in these buried portions of the Witwatersrand supergroup is sometimes carried out at depths of 4 kilometers below the surface. Geological origin. The Highveld craton, one of the first microcontinents to form on Earth through plate tectonics, was assembled about 3,900 million years ago. Its size and position relative to southern Africa today is indicated in the diagram on the left. About 3,000 million years ago local cooling of the underlying asthenosphere caused subsidence of the southeastern portion of this microcontinent below sea level. The floor of this newly formed Oe Witwatersrand consisted of smoothly eroded granites. Sandy sediments brought in by rivers from the north started being deposited on the granite about 2970 million years ago. This sandy layer eventually became compressed to form the Orange Grove quartzite, the lowermost layer of the Witwatersrand supergroup. This quartzite formation forms the scarp from which the Witwatersrand derives its name. As the sea deepened, finer grained and muddy sediments accumulated. There was no free oxygen in Earth, a unregistered trademark S atmosphere till about 2,000 million years ago, but there were photosynthesizing cyanobacteria. The oxygen these microorganisms produced rapidly reacted with, amongst others, any dissolved iron compounds in the water, producing insoluble red iron oxide, which precipitated out during the daylight hours. At night these reactions stopped. The result was alternating red and gray layers of mud which, when consolidated, became banded ironstones. Fluctuating sea levels resulted in the accumulation of a further variety of sediments, ranging from mud, to sand, to gravel, and banded ironstone. Tillite deposits, dating from 2950 million years ago, are indicative of the first glaciation episodes on Earth. Within 60 million years, 4,300 m of sediment had accumulated on the granite base, to become the West Rand group of rocks that contribute over 60% of the total thickness of the Witwatersrand supergroup. Uplifting of the north of the Highveld craton, in addition to regenesis, towards the end of the deposition of the West Rand group of sediments caused the Witwatersrand sea to retreat. The area of the craton on top of which Johannesburg is now situated, became a vast riverine plain, which extended along the entire northern and western shoreline of the shrunken sea. The rivers formed braided deltas with many interlacing, slow-flowing channels where all the heavy materials brought down from the mountains were deposited, large pebbles, and heavy minerals, such as gold, iron pyrite, and uraninite. The gold was in its elemental metal form. Cyanobacteria grew in relative abundance in these mineral-rich waters. The corrosion that is found in association with the gold deposits almost certainly represents what remains of these Archean photosynthesizing microorganisms. It is clear that for the next 200 million years the floodplain was repeatedly inundated, sometimes eroded, and sediments redeposited. The result was a 2,500 m thick layer of rock that is termed the Central Rand group which together with the West Rand group forms the Witwatersrand supergroup It is the younger group of rocks that contains the gold-bearing conglomerates that are today of great economic importance. The largely underground horizontal extent of the Witwatersrand supergroup is known as the Witwatersrand Basin. The ultimate source of the gold is unknown, but that it is restricted to the areas of the craton unregistered trademark S coastal plain where the rivers flowing into the Witwatersrand Sea formed braided deltas, indicates that the source was in the mountains to the north. The Welkom, Krugersdorp, Carletonville, West Rand, East Rand and Evander gold mines are all situated over these Archean fan deltas. The Central Rand group of deposits was brought to an abrupt end by massive outpourings of lava, which form the Bedfordview lavas which erupted 2714 million years ago. The cause of these lava outpourings is a matter of speculation. It might be related to the collision of the Highveld craton with the Zimbabwe craton, eventually to become knitted together to form a single continental unit. A final event that had a major impact on the geology of the Witwatersrand supergroup and its exposure in the Johannesburg region, was a massive meteor impact 110 kilometers to the southwest of Johannesburg 20 million years ago. The epicenter of the impact was close to the present village of Bedfordview, which has given its name to the geological remnant of this immense event, the Bedfordview Dome. Not only are the remains of this impact the second oldest on Earth, but it is also the largest meteor impact that has left its imprint on the Earth, a unregistered trademark S geology of today. A meteor 15 kilometers across created a 300 kilometers diameter crater, distorting all the rock strata within that circle. Johannesburg is just within the outer edge of this impact crater. In the immediate vicinity of the impact all the subterranean strata were uplifted and upturned, so that Witwatersrand rocks are exposed in an arc 25 kilometers away from the impact center. There are unfortunately no gold deposits in these outcrops. The meteor impact, however, lowered the Witwatersrand rocks within the crater. This protected them from erosion later on. But, possibly more importantly, bringing them to the surface close to the crater rim, near Johannesburg. In fact, apart from the Witwatersrand outcrops in the immediate vicinity of the Beaufort Dome, virtually all the other outcrops occur in an arc approximately 80–120 km from the center of the impact crater, to the west, northwest, north and northeast. Thus, it is possible that if it had not been for the Beaufort meteor strike 2,000 million years ago, we would either have never discovered the rich gold deposits beneath the southern African surface, or they would have been eroded away during the extensive removal of the surface of the southern African plateau during the past 150 million, and more especially during the past 20 million years. Consequences of mining the ancient Witwatersrand rocks, apart from the obvious hollowing out of the rocks below southern Johannesburg, causing unpredictable sinkholes, surface instabilities and earth tremors, the bringing to the surface of rocks that had been laid down in oxygen-free conditions had unforeseen effects. Iron pyrite, which is relatively plentiful in the gold ores of the Witwatersrand, oxidizes to insoluble ferric oxide and sulfuric acid. Thus, when mine waste comes into contact with oxygenated rainwater, sulfuric acid is released into the groundwater. Acid mine drainage, as the phenomenon is called, has become a major ecological problem, because it dissolves many of the heavy elements, such as the uranium, cadmium, lead, zinc, copper, arsenic and mercury found in the mine dumps, facilitating their passage into surface water and groundwater. Sulfuric acid also erodes concrete and cement structures, resulting in structural damage to buildings and bridges. History. Although gold had been discovered in various locations in South Africa, such as Barberton and Pilgrim's Rest, as well as at several sites near the Witwatersrand, these were alluvial concentrates in contemporary rivers, or in quartz veins, in the form that gold had always been found elsewhere on Earth. When George Harrison, probably accompanied by George Walker, found gold on the farm Langlaagte, 5 kilometers west of the city of Johannesburg, in an outcrop of conglomerate rocks, in February 1886, they assumed that this was alluvial gold in an old riverbed that had been tilted as a result of earth movements. However, when it was found that, traced down dip, the conglomerate was not merely developed for the narrow width of a river, but continued in depth, there came the realization that this conglomeratic zone was part of a sedimentary succession. Harrison had stumbled on the main reef conglomerate. The conglomerate was quickly traced east and westward for a total continuous distance of 50 kilometers to define what became known as the Euro Central Rand Goldfield Euro. Harrison declared his claim with the then government of the Zuid-Afrikaanse Republiek, and in September 1886 President Paul Kruger issued a proclamation declaring 9 farms public mining diggings, starting on September 20, 1886. This heralded the historic Witwatersrand gold rush. Harrison is believed to have sold his claim for less than £10 before leaving the area, and he was never heard from again. Harrison Euro unregistered trademark S original Euro Isla Cursor Euro claim No 19 was declared a national monument in 1944, and named Harrison Euro unregistered trademark South Park. The park is on the busy Main Reef Road, immediately west of Norswreck Road. In 1887 Cecil John Rhodes registered a Euro the Gold Fields of South Africa Euro and London, South Africa Euro unregistered trademark S First Mining House, with a capital of £250,000. His brother Thomas was the first chairman. See also, Geography of South Africa, Great Escarpment, Southern Africa, Beaufort Crater, Witwatersrand Basin, List of mountain ranges of South Africa, Pilanesberg, Borrokhalilo Game Reserve. Further reading, Breckenridge, Keith Derrick An Age of Consent, Law, Discipline, and Violence on the South African Gold Mines, 1910 Euro 1933. Ph.D. Thesis, Northwestern University, Evanston, Ill. Kamak, Diana The Randit War, The Witwatersrand and the Anglo-Boer War 1899 Euro 1902. London, James Curry, Hurd, Norman 1922, The Revolt on the Rand. Johannesburg, Blue Crane Books. References. External links. Relationships between the default structure and the Witwatersrand basin within the tectonic framework of the Highveld craton as interpreted from regional gravity and aeromagnetic data, Johannesburg Geology.